a very extensive multi-step variables on both sides linear equation, but I made it extensive so that way you could see all the steps that you would have to go through. So the very first step, your step one, is always to check to see if you can distribute. So I want you to go ahead and highlight that in blue. You're going to distribute if possible. All of these things are going to be statements of if it's possible. If you can, that's what you're going to do. This is going to be your step number one. So whenever you're looking at any linear equation, the first thing that you're going to do is see, is there anything that I can distribute? And in order to distribute, that means that you've got a term, a value outside of parentheses that is multiplied to an expression that is inside of parentheses. So right here in this situation, we do have one value, the 2, that can be distributed. And I'm going to go ahead and zoom in onto this so you can see it easier. It can be distributed to the 2 terms that are inside of this parentheses set. The parentheses is indicating that this is a quantity that needs to be multiplied by the value 2. So what you would be doing is you would be multiplying 2 times 3x, which I'm showcasing right here, 2 times 3x. And then you would also be distributing the 2 to this component, which happens to be a -5. So going back to 6th grade and possibly 5th grade, your operations of addition and subtraction separate your terms. So this is a positive 3x. When you separate them, this becomes a -5. That -5 takes on a -5 quantity. Okay, so you're doing a 2 times a -5. 2 times -5. And by doing so, it changes to the following expression. You now get 6x minus 10. You now get that expression of 6x minus 10 once you're done distributing. Notice everything else in the problem just comes straight down and has not changed. The only thing that has changed is what we've distributed. So that is always step one. You're always looking to see if there's anything that you can distribute in any situation, any equation. And again, linear equation. And we'll talk more about what linear equations are next semester. Okay, our second step, step number 2, is to combine like terms on the left side of the equation and then combine any like terms on the right side of the equation. Okay, so combining like terms on the left side of the equation, bear with me. I'm going to be doing this in green and in pink for combining. So highlight like I am, just because it's showing you that the left side, we're showcasing combining like terms in pink and green, because you've got variable terms that you'll highlight and you've got non-variable terms called constants that can be combined together. So that's on the left side. And then on the right side, you're going to combine like terms as well. So you're going to combine the like terms on the right side of your equation. So I'm going to do that in purple and orange. I'm just trying to make sure that you have it looking exactly like what the board has. So let me go over what is considered to be those like terms. So looking on the left side of the equation, so the equal sign is what splits it into sides. On the left side, we happen to have a 6x, and we have a negative x. We have a 6x and a negative x. So we can combine those together by doing 6x minus 1x. Where did that 1 come from? Why did I put a 1 there? Anybody know why, instead of just writing minus x, why did I put minus 1x? Armando? Because it is 1x. There's called the invisible math. Remember, we've talked a couple of times about invisible math, that every single number can be written as a fraction by putting it under, or putting a 1 under it. You can change every single number into a decimal by adding 0.0 to it. you can write every variable with a coefficient by writing a 1 in front of it if it doesn't have a coefficient present. So we write the invisible 1. Every variable has a coefficient. Even if it's not written, it just means it's a 1. Okay? We also have our constants. Our constants happen to be like terms. So we've got a negative 10 and a positive 6. A negative 10 and a positive 6. Again, that minus sign in front of the 10, when we separate these into individual terms, we adopt that minus sign as a negative. Okay, so it now becomes negative 10 plus 7. All right, and then we just simplify those. So 6x minus the 1x is where we get 5x from. And then negative 10 plus 7 is where we get a negative 3 from. Then we do the same on the right side. On the right side of the equation, we're going to go ahead and combine the variable terms that we have. So we happen to have a negative 3x and a positive 5x. So we're going to combine those together. Negative 3x plus 5x comes out to a positive 2x. Negative 3x plus 5x comes out to a positive 2x. And then we have a positive 9, but we don't have any other like terms with it, so it just stays a positive 9. So we now get the expression 2x plus 9. So again, step 1, distribute if you can. If there happens to be something that needs to be distributed, you do that first. Once you're done with any distribution, you then go and look to see if there's like terms that you can combine on both sides of the equations. You're trying to simplify both sides down to single terms. Okay, one term in variable x, one term in constant. All right, once you've done that, if you happen to have variables on both sides of the equation, then what you're going to do is you're going to move the smallest of the two variables by either addition or subtraction. It's called doing an inverse. Okay, so far everything we've done the exact operation it's told us to, haven't we? And usually with equations, we think of opposites, doing inverses. But so far for steps 1 and steps 2, we've done exact operations that it said. It said to add them, we added them. It said to subtract them, we subtracted them. Now, the difference here is we're moving to opposite sides of the equal sign. We're taking one of the variables and moving it to the other side. So if we're moving it to an opposite side, that's when opposite operations happen. That's when you have to do an inverse. If it's on the same side, you do the same operation it tells you. If it's on opposite sides, you do opposite operations. Does that make sense? Okay, that's how you keep it balanced. So for here, I'm going to go ahead and I know we've already used purple, but we're going to use purple again. We're going to highlight this whole thing in purple. So this step, if it's there, if you have variables on both sides, you're going to choose the smallest. Now, you don't have to go with the smallest. I think it's easier to go with the smallest because then it negates out any of those negatives. A lot of times the mistakes come from those negatives, so this helps to get rid of the negative for a time being. Okay, so I always say to go with the smallest. So I would circle the word smallest. So looking at my two variables, we've got a 5x and we've got a 2x. They're both positive. So which one's smaller, 5 or 2? 2. So what I'm going to do is I'm going to take my 2x, and since it was a positive 2x, I'm now going to subtract 2x from both sides. I'm subtracting 2x from here. I have to subtract 2x from the other side as well. Whatever I do to one, I must do it to the other. And that helps to cancel it out here. And now we're just going to work through the problem on this side. What does 5x minus 2x give us? Gives us that 3x. Okay, everything else in the problem just comes straight down. We still have a minus 3. We still have this plus 9, which now becomes a positive 9. And now it's a two-step equation. Once you've gotten rid of the variable on both sides, you should be down to two-step equations. And from here, you should know what you are doing. Ray? Mm-hmm. So because we're moving the entire term, when we divide, what we're trying to do is keep the variable positioned where it is and get rid of just the coefficient. Here, we're not trying to get rid of just the coefficient. We're trying to move the entire term. We're moving the coefficient and the variable to the other side. So because of the fact that we're moving the entire x term, it's an addition or subtraction. Okay, when you are trying to isolate the term by getting rid of a coefficient, that's when you do multiplication or division. Okay, all right, so for here, you're now at a two-step equation. You should know what you're doing with two-step equations. You will start by getting rid of the constant. And remember, the constant is the value that is just a number. It's a number that is either being added or subtracted in the expression, okay? And it happens to be right here. We're going to go ahead and, I don't know why this got moved. It should have been over to the other side. But we're going to go ahead and do the inverse operation of subtracting the 3 by adding a 3. We're going to add a 3 to both sides. And 9 plus 3 is going to give us that 12. 9 plus 3 gives us 12. And of course, the 3x just comes straight down. And now we're at a one-step equation. And with our one-step equations, you either multiply or divide. In this case, because it's a coefficient, we would divide both sides by the 3. And then 12 divided by 3 gives you 4. Okay, so let me reiterate again the steps. Step 1, always, 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 is to check and see if you can distribute. If you can, then do it. Step 2 is to always combine like terms on both sides. Simplify each expression separately. Ignore the right side, simplify what you can. Ignore the left side, simplify what you can. So that you are now down to just a single variable and or a single constant. Step 3, if you happen to have variables on both sides, you pick the smallest of the two variables and do the opposite of it. If it was a positive, you do minus. If it was a negative, you will add, okay? Then you have it down to two-step and or one-step equations. If it's a two-step equation, you get rid of the constant by addition or subtraction. And then once it's a one-step equation, you get rid of the coefficient or the divisor by multiplying or dividing. Any questions? Okay, so based off of that, let's take a look and see how you did yesterday on your warm-up. So remember, I asked you to go ahead and complete the warm-up as best as you could. If you didn't have a chance to go through, or if you skipped around and do all the problems because you didn't understand them, hopefully you'll understand them a little bit better today. So for here, problems 1, 2, and 3, these are all single-step equations, one-step equations. For problem number 1, x minus 7 is equal to negative 15. We don't have a coefficient, but we do have a constant. So what we're going to try to do is isolate the variable by the inverse of the constant. What is the inverse operation here? Addition, right? We would add 7 to both sides. And by doing so, you guys should have gotten x is equal to a negative 8. Same thing for problem number 2. We have 5 plus m is equal to 13. 5 plus m is equal to 13. We're going to move the 5 to the opposite side. Because the 5 is a positive, and keep in mind that plus sign does not belong to the 5. It belongs to the m. It belongs to the m. So here, the biggest mistake, and I'm going to write this up at the top, biggest mistake I see kids make all the time is when they see 5 minus m is equal to 13, what do you think they automatically want to do? They're like, oh, we're going to add 5 to both sides. But if I add 5 with 5, is that going to get rid of the 5 here? No, 5 plus 5 is going to be 10. So I just made my expression 10 minus m is now equal to 18. Okay, your opposite operation is based off of what is in front of the value, not what's behind it. What's in front of this value is a positive, so you'd have to subtract the 5. That minus sign belongs to the m because it's in front of the m. It's in front of it, it belongs to the m. So this is actually a 2-step equation right here. A lot of people think it's a 1-step, but it's actually 2-step. When you solve this, you would subtract your 5 from both sides. You would be left with a negative 1m is now equal to 8. And then you would have to divide both sides by negative 1. And you would get m is equal to negative 8. Okay, so this right here is a 2-step equation. All right, let's go back to this. So here we would subtract the 5 from both sides, and we would get m is equal to a positive 8. Problem number 3, you have 8 times w. When they're side by side, that means multiplication, so we would divide both sides by 8, and that would give us w is now equal to 4. Okay, for problem number 4, 2-step equation. So when it's a 2-step equation, we get rid of the constant, then we get rid of the coefficient or divisor. So the constant in this case is going to be the 8. We're going to get rid of a minus 8 by adding 8 to both sides. That leaves you with 7x is now equal to 28. You then would divide both sides by 7, and you would get x is equal to 4. Problem number 5, 3x plus 11 is equal to 35. You should have subtracted 11 first from both sides. That would give you 3x is now equal to 24. You then would divide both sides by 3 and get x is equal to 8. Problem number 6, x over 4 is equal to x over 4 minus 9 is equal to 7. You would add 9 to both sides first. That would give you x over 4 is now equal to 16. You would then multiply both sides by 4, and you would get x is equal to 64. Okay, problem number 7, that's one of those distributive property questions first. So we would have to distribute the 5 times the 4x and the 5 times the negative 3. So 5 times 4x is going to give us 20x, and then 5 times negative 3 is going to give us negative 15. So we have 20x minus 15, and that's still equal to 25. It's now down to a 2-step equation. You would have added 15 to both sides. That's going to give you 20x. Oh, I should have done that in the black, sorry. That'll give you 20x is equal now to 10. Or, no, I'm sorry. Is equal to 40. And then you're going to divide both sides by 20. And you'll get x is equal to 2. Okay. For problem number 8, again, you would distribute. You would do 2 times 6f, and then 2 times 4. That's going to give you 12f plus 8. 12f plus 8, and that's still set equal to a negative 28. You're now down to a two-step equation. So you would subtract 8 from both sides first. That's going to give you 12f is now equal to a negative 36. And then you would divide both sides by 12. And you would get f is equal to negative 3. For problem number 9, distributing the negative 6 to both components. So negative 6 times 3y and negative 6 times negative 7. Negative 6 times 3y gives you negative 18y. Negative 6 times negative 7 gives you a positive 42. So you should have had negative 18y plus 42, and then that's equal to 24. You would then go ahead and subtract the 42 from both sides. That's going to give you a negative 18y is now equal to a negative 18. You would then divide both sides by negative 18. And you get that y is equal to a positive 1. So far, so good? Awesome. All right, problem 10, 11, and 12, those are just combining like term practices. So for a case like this, we would go ahead and combine the 3x and the 6x together. 3x combined with the 6x is going to give you 9x. So you have 9x is now equal to 45. You would then go ahead and divide both sides by 9, and you would get x is equal to 5. That's a simple one. For problem number 11, you would have combined 8x and a positive 3x together first. 8x plus 3x is going to give you 11x. Then you would focus on the positive 15 and the negative 24. 15 minus the 24 is going to come out to a negative 9. Or minus 9. And then that's going to be set equal to 57. We would then go ahead and add 9 to both sides. That would give us 11x is equal to 66. And then you would divide both sides by 11. I don't know about y'all, but I love doing equations. It's just like a rhythm you get into. This is the nerd side of me coming out here. Yeah. Huh? I haven't gone over problem 12 yet. So I'm going to go over it right now. Wait to be confused until after I go over it. Okay, so for problem number 12, you would be combining your like terms, right? We combine 5x and a positive 2x. What's 5x plus 2x, guys? 7x. So we should have 7x here. Then we've got a negative 11, right? That minus 11 acts like a negative 11. We have a negative 15 because that minus 15 acts like a negative 15. When we do negative 11 minus the 15, that's going to come out to a negative 26. And then that's set equal to a negative 47. So far, so good? Right? Combined your like terms, things that can be combined together, you combine them together. Don't forget to include the operation in front of it to take on the sign. Okay, from here, inverse operation is to add 26 to both sides. What do we get when we do negative 47 plus 26? Negative 21. Good. So we're going to have 7x is now equal to a negative 21. And then the last step is to just divide. Divide both sides by 7. You're going to get x is equal to negative 3. Still confusing? Right? No? Sometimes it just, when they look a little larger, they can become overwhelming. You just have to, again, break it down by steps. Go, okay, do I have any distributed property? No. Can I combine any like terms? Yes. So let me go ahead and do that. Okay, are there any more like terms? No. All right, now we're going to go on to solving. Do I have variables on both sides? No. Do I have a constant? Yes. Let's get rid of the constant. Do I have a coefficient? Yes. Let's get rid of the coefficient. You just work through each of those step by step by step. Okay? All right. Problems 13 through 15. Variables on both sides. So again, like I said, when you're moving the variables on both sides, the easiest thing to do is focus on the smallest of the two variables. Which variable is the smaller of the two variables for number 13? The 2x. So we're going to go ahead and instead of a positive 2x, we're going to subtract a 2x from both sides. So I can cancel it out here. And then what is 8x minus the 2x? 6x. So we have 6x. We still have a plus 3. And that's now going to be equal to what? What's the right side? What's left on the right side? Negative 9. See, at minus 9 now becomes a negative 9. Biggest mistake? Kids just drop the negative. They don't include the negative, and then that completely changes the answer. If they put a positive 9 here, they would have gotten x is equal to 1. Be honest, anybody get x equals 1 as their answer? No? Oh, you did? Okay, because you dropped the negative. Be careful. Don't drop the negative. That negative has to come down as well as the number. So it's a minus 9. I'm going to draw double arrows to show that the minus sign comes down and the 9 comes down. So it's equals a negative 9. Okay, from here, we can then just solve the two-step equation. We're going to subtract 3 from both sides. That's going to give us 6x is now equal to negative 12. And then we'll divide both sides by 6. X is equal to negative 2. Okay, for problem number 14, which one of those is the smaller of the two variables? Nope. Negative 9x. Negatives are always smaller than positives. Negatives are always going to be smaller than positives. So we're going to focus on getting rid of the 9x first. So instead of a negative 9x, we're going to add 9x. So the opposite of a negative or a minus sign is a positive or a plus sign. So we're going to add 9x to both sides. Okay, that leaves us with a positive 12 is now equal to 13x minus 27. And it's okay for you to have the variable on the right side. Nothing wrong with that. Okay, from here, our inverse operation, we are going to add 27 to both sides. That's going to give us 39 is now equal to 13x. And then our last step is to divide both sides by 13. And you'll get 3 is equal to x, or you rewrite it as x is equal to 3. All right, the last one. Negative 3x plus 11 is equal to negative 7x plus 31. Which one of those is the smaller of the two variables? Negative 7x. Good. All right, so negative 7x is the smaller of the two. So instead of the negative 7x, we're going to say plus 7x. So we're going to add 7x to both sides. Negative 3x plus 7x is going to give us 4x, becomes a positive. Everything else stays the same. We still have that plus 11. and it's equal to a positive 31. That plus 31 is a positive 31. We would then subtract 11 from both sides. That's going to leave us with 4x is now equal to 20. And the last step is to divide both sides by 4. You'll get x is equal to 5. My suggestion to you is to always keep the sheet close by. Whenever you're doing anything involving equations, I mean, at the beginning, when it's just one-step and two-step equations, it's not that big of a deal. But when you start getting into really extensive equations, multi-step equations that have variables on both sides and distributive property and combining those like terms, it can get overwhelming. Have that sheet that explains each step there, because it's a checklist. It's just a simple checklist for you. And it might seem odd that we just did a whole bunch of equations when the unit is geometry, but you have to know how to solve equations in order to do this portion of geometry, which is identifying missing values in angle relationships and triangles. Okay? It'll make a lot of sense once we start going over it. And some of you probably have already started going through the notes and previewing it, and that's great. Let's take a look. Go ahead and flip it on over. We're going to talk about vertical and adjacent angle relationships today. These are two types of angle relationships. When we're talking about a relationship, in order for a relationship to exist, there has to be more than one person involved, right? I mean, you can't have a relationship with just yourself. You have to have a friendship with somebody. You have to have a companionship with somebody. It's the same thing here with angle relationships. There has to be more than one angle involved in order for a relationship to exist. Otherwise, an angle is just an angle type and not a relationship. So vertical is just a set of two angles that are opposite to each other, and they're congruent. Congruent means equal. They are equal in size and measure. Okay, so when we're looking down here at this diagram, I'm going to reference this diagram for the time being. We have intersecting lines that are going to form these angle relationships. So in this situation, angle, and I think I'll use pink, angle A and angle R. Angle A and angle R are considered to be vertical angles. So based off of the example below, angle A is vertical to angle R because they are directly across from each other. Kind of think of it like neighbors. If you live in a neighborhood, you have how many next door neighbors? At most, you can have how many next door neighbors to you? 2, right? You can have one on one side and one on the other side. Next door neighbors, next door to you means that you share something in common. Okay, maybe your fences are backing up to each other, or or side by side. You have 2 neighbors that are side by side next door to you. Then you've got a neighbor that is across the street. How many neighbors can be directly across the street from you? 1. Okay, so adjacent relationships are like next door neighbors. You can have 2 next door neighbors. So that means that every angle has 2 angles that they are adjacent to. But vertical relationships, you can only have 1 vertical angle relationship. You can only be directly across the street from 1 neighbor. And maybe you don't have one that's directly across the street from you. But if you happen to, it's only going to be 1 person. So the easiest way I can describe it is if you were to identify the angle and draw a line straight towards the vertex, which is the corner piece, and then continue that straight line, it's going to end up at the next angle. That straight path, it has to be a straight path that connects the 2 angles together through the vertex. If at any point you have to curve that line or bend that line to get to another angle, then it is not a vertical angle relationship. They have to be directly straight across from each other. Does that make sense? Okay, so because of the fact that angle A and angle R are vertical angles, that means angle A is equal to the measurement of angle R. And then the same thing can go for here. Angle X and angle M. Angle X and angle M are also vertical angles because they are directly across from each other. So I'm going to write that here. Angle X is vertical to angle M. So that means that angle X is equal to angle M. They are equal relationships. All right, then we've got our adjacent. Like I said, adjacent is our next door neighbors. So notice that I say they share a common ray or wall, right? These lines are called rays, but you can think of them as walls. And a vertex. They have a common vertex or a point, a corner. Okay, so if we are looking at angle, we'll start with angle A. If I start at angle A is going to be adjacent with angle X. So angle A and angle X are adjacent angles. But angle X has another neighbor. Who's its other neighbor? R. Next door, directly next door, is angle R. So angle X and angle R, they are also neighbors. Is A neighbor with R? No, because it's a vertical relationship. If it's vertical, it can't be next door. Okay, vertical angles cannot be next door angles as well. They cannot be adjacent and vertical at the same time. Okay? All right, angle R also has another neighbor. What's angle R's other neighbor? Angle M. And then angle M has another neighbor. It is angle A. Okay, so what I want you guys to do with this bottom diagram is I want you to identify the vertical angle relationship. And I'll let you know right now there are only two angles that create a vertical angle relationship in this diagram. So you'll only have one relationship here. And then I want you to identify all of the adjacent angle relationships. Tell me the two angles that create the vertical angle relationship and tell me all of the adjacent angle relationships that exist. Okay, so the vertical angle relationships, who can raise their hand, tell me what two angles is going to create the vertical relationship here? Ewa? R and X, yes. So X and R are directly across from each other. Directly across from each other. I've had kids in the past who thought that, F and M or F and B would also be an angle relationship for vertical. But remember, if you were to create a line, at some point you would have to curve it or bend it to be able to get to the other. So you don't want to include those. So angle X and angle R are the vertical angle relationships here. The adjacent ones, I'm just going to go through those real quickly so that we can move on. Angle X and angle M. Then we have angle M and angle B. We have angle B and angle R and angle F, and then angle F and angle X. Okay, it just kind of basically goes around as a circle, right? Wraps its way around to each of those relationships. Now, if you notice, however many angles you have is the same number of adjacent relationships, isn't it? Okay, we got 5 angles, we've got 5 relationships. In the first one, we had 4 angles, we had 4 adjacent relationships. So the number of angles that you have in the diagram is the number of relationships for adjacent that you will have. Okay? All right, let's go ahead and move on to the back using the vertical angle information. The fact that vertical angles are congruent angles, that means we can solve for missing values based off of this relationship. We can set this up by saying 2x and 70 are vertical angles. Therefore, that means 2x is equal to 70. Because of the fact that they are vertical angles, we can set them equal to each other and then solve. How would we solve? 70 divided by 2. We would just divide both sides by 2, and that's going to give us x is equal to 35. For problem number 2, we've got 3x minus 1, and we've got 155. Again, these are vertical angles, so we can set up the equation 3x minus 1 is equal to 155. What's the first step? Plus 1. That's going to give us 3x is now equal to 156. Next step, divide by 3. Dividing it by 3, we're going to get x is equal to 52. Okay, for problem number 3, again, these are vertical angles. We have x plus 16 is equal to 4x minus 5. X plus 16 is equal to 4x minus 5. What's the first step here going to be? Very good. And how are we going to move it? Are we going to add it or subtract it? Subtract it. This is a 1x. I'm going to put a little imaginary 1 in there. So I'm going to subtract 1x from both sides. That's going to give me a positive 16 is now equal to 3x minus 5. We'll then add 5 to both sides. That's going to give us 21 is equal to 3x. And then we'll divide both sides by 3. And we'll get x is equal to 7. All right, 12x plus 10 is equal to 5x plus 31. So again, we're going to set them equal. 12x plus 10 is equal to 5x plus 31. First step, get rid of the 5x. So we're going to subtract 5x from both sides. Subtract 5x from both sides. That's going to give us 7x plus 10 is equal to a positive 31. Next step. Minus 10, subtract 10 from both sides. That gives us 7x is equal to 21. Last step, divide by 7. Okay, we'll get x is equal to 3. Okay, on the back side of this paper, it talks about complementary and supplementary angle relationships. Complementary and supplementary angle relationships are the two angle relationships that probably get the most confused because, you know, they have the same idea, the same concept, but they are equating to different values. So for complementary angle relationships, you have two or more angles that are going to have a sum of 90 degrees. That means you're going to add them together and it's going to equal 90 degrees. For supplementary, it's two or more angles that when you add them together it equals 180. Here's how I've had students remember it in the past. There's two different methods. One student brought up the fact that complementary and supplementary, if you find them in the dictionary, which one comes first? Complementary comes first. Complementary starts with a C, supplementary starts with an S. And if you look on a number line, what are you going to find first, 90 or 180? 90. So complementary comes first in the dictionary, 90 comes first on the number line. They both come first together. So that's how they've paired those up, and supplementary and 180 comes together because they both would be later in the dictionary and number line. Another student says she remembered it once because she thought complementary, well, if I say that, and 90 degrees is called what kind of angle? A right angle. So she said, Miss French-Zheng, if you tell me that I'm always right, you're paying me a compliment. So that's how she remembered it. I thought that was kind of unique. So if you know that it's complementary angles, they're forming right angles together. Together they create a right angle. Telling you you're always right is paying you a compliment. Okay? Whatever helps you to remember that complementary adds up to 90 and supplementary adds up to 180, go with it. Okay? So real quickly, on these three, identify which relationships is complementary, supplementary, or neither. There doesn't have to be a complementary or supplementary relationship at all. So identify them quickly. Okay, real quickly, looking through here, 53 and 127, if we were to go ahead and combine those together, 53 plus 127 is going to equal 180. That makes it supplementary. Okay, for here, 56 and 34, if we were to go ahead and take 56 and add it with 34, that's going to equal 90, so that makes it complementary. And then with this bottom one, number 3, if we take 30 and add 39, that's going to come out to 69. That's neither relationship. Okay, and now you can use the complementary and supplementary relationships to also solve for angles. Knowing that this is forming the L shape and it has that nice lovely little box there as well, that means it's creating a complementary angle set. So what I can do is I can set this up as x plus 68 is supposed to be equal to 90. And then I can solve it. Oh, sorry. Thank you. X plus 68 is equal to 90, and then you can solve it. You would subtract 68 from both sides, and you would get X is equal to 22. Very, very simple. I know I'm rushing right now because we only have 2 more minutes left. So what I'm going to do is I'm going to show you how to set up the rest of these equations. You should be able to solve them, and then you can go on tonight and I will show a picture of the last page showing how to solve them all as well. But let me show you at least how to set up the others. What kind of relationship is number 2? Supplementary. So if we're setting it up, we would set it up as 2x plus 36 is equal to 180. Write that down. 2x plus the 36 is equal to 180. For number 3, the first thing that you would need to do is identify the relationship between the 2x and the 120, which is also supplementary. You would have 2 separate equations. You're going to have 2x plus 120 is equal to 180. And then when you're trying to solve for your y, your y, that is a vertical angle relationship there. So for your vertical angle relationships, you're going to set this up as 3y plus 30 is equal to 120 because they are vertical angle relationships. For problem number 4, we're dealing with the supplementary angle relationship here. I'm sorry, the complementary angle relationship here. So we would have 6x plus 10 as one angle. We're adding it with the second angle, which is 20, and that's going to be set equal to 90. So you'd have to combine like terms and then do opposites. And then the last one, this is a supplementary angle relationship. So you'd have the first angle, 4x minus 50. You would add it with the second angle, plus the 70, and that should be equal to 180. That's your supplementary relationship. Okay, again, tonight I will post a picture of this last page showing the step-by-step directions of solving. Tomorrow for Digital Day, you will have IXL solving for missing angle relationships. Your IXL will be to solve for missing angle relationships. What's the max score that you need? 70, or I'm sorry, the minimum score. The minimum score you need is a 70. Your max score, 80. All right.